Imagine you are in a casino that offers an interesting game of cards. It costs only $1 to play, so we want to give it a try. There is a deck of cards on the table, exactly the same number of red and black ones. You can't see the colors and you have to pick up a random card. If it's red, you get $1 and continue playing by putting the chosen card back and picking up one again. Although if it's a black card, the game ends immediately. Let's take a look at some examples. If you get 3 red cards in a row and then a black card appears, you get $3 and you finish the game at turn 4. Remember, each game like this costs you $1, so you earned $2 here. Another example shows that if you are unlucky, you might end up losing the dollar you paid. Summing up all the facts, we have rules like this. Each game costs $1. You pick up one from a deck of cards. If the card is red, you get $1. You put your card back and pick up one again. If the card is black, the game ends and you win the amount of money you collected during the previous turns. How do you think? Is it a fair game? If you played it many times, would you expect to earn or lose the money? You can pause the video and think about the problem yourself. Here comes mathematical solution and experimental method. At the beginning, we have 50% chance for positive result and 50% for negative result, which makes us end the game immediately. If we got $1, there are 2 ways again. Chance for getting another $1 and chance for ending the game winning just $1. We could continue drawing such a tree, but it's endless. The thing we need to find is an average amount of money that a player wins again. Let's assume X is the average price. If X is greater than cost of the game, it means the game is worth playing. Analyzing the diagram, we can notice something. In positive case, after first turn, we get $1 and we are in the same situation as at the start, but with $1 more in a wallet. Now the expected win is X plus $1. We are at the most complicated moment right now. By law of total expectation, we can write an equation like this. Why? Because it tells us that an expected value is equal to the sum of expected values after possible events times probability of the events to happen. And 50% is just 1/2. So we get X is equal to 1/2 times $0 plus 1/2 times X plus $1. Now it's just a simple equation to solve in a few steps. We can get to the conclusion that says average price is exactly $1. It means the game is completely fair, and if you played it for hours, you would likely stay with a similar amount of money that you had at the beginning. There is also an experimental solution. We are going to simulate million games. Let's take a look at this algorithm. We will count amount of earned cash and number of played games. If we haven't played million games yet, we start a new one and randomize a card. 50% for a red card, which is good for us, and 50% for a black card, which is bad. Every time we get positive result of randomization, we add 1 to our cash, and every time we get negative result, we add 1 to our games counter. After million games, total cash divided by all played games is average win. Here you can see how I implemented it in a programming language C++. Time to try it out. It shows us values that are really close to 1. That method isn't perfect, but it is good enough to make us realize that the game is fair. So we have 2 ways to solve the problem, but the mathematical one is more precise. I find probability problems very interesting, and coding is really helpful as a tool for making simulations. And that's the end of my presentation. Thank you for watching the video, and bye-bye.